Right, we're going to be solving more of the equations with rational exponents and then also more square root equations today. Okay, so we looked at 54 yesterday was where we left off. So we're going to be doing the same thing with 55. So first thing, I would suggest dividing by -2. So divide by -2. You're going to get x to the 3/4 equals 8. Okay, to undo that exponent of 3/4, you're going to take it to the exponent of 4/3. Okay, now this simplifies to x, and then this 4/3, I'm going to rewrite that as a root. So the denominator is the root, the numerator becomes the exponent. Okay, so then cube root of 8 is 2, and then to the 4th power, x is 16. Okay, number 56, we're going to divide by that -2/3. Well, instead of dividing, I'm going to multiply by -3/2. So -3/2. That's going to give you x to the 1/5 power equals 3. And for this one, we're just going to take it to the 5th power because 5 is the reciprocal to 1/5. So x equals 3 to the 5th power, or that ends up being x is 243. Okay, now moving on. Number 57. On this one, we're going to do the exponent first. So we're going to take this to the 2/5 power. And then you'll have x plus 3 equals 32 to the 2/5. If I rewrite that, using a radical, the 5 becomes the root, the 2 is the exponent. So x plus 3 equals, the 5th root of 32 is 2. So if you did a factor tree, you would get it factored down and you would have a set of 5 2's and with no remainders. So then this is x plus 3 is 4, and then subtract the 4 and you will get 1. Okay, 58 similarly. So get rid of that exponent. We're going to take it to the 3/5 power. So 3/5 power. So this is x minus 3 equals 243 to the 3/5. Well, that's going to be the 5th root of 243 and then cubed. So we saw actually on a previous one that 3 to the 5th was 243. So the 5th root of 243 is 3, and then that's going to be cubed. So that equals 27. Move the 3 over to the right, and x is 30. Okay, so similarly with 59, but first thing I'm going to move this 3. So I have x plus 3 to the 1/3 power equals 4. And then the reciprocal is 3. So I'm going to take it to, I'm going to cube everything. So take that to the 3rd power. You're going to get x plus 3 equals 64. Move the 3. X is 61. Okay. All right, now we're back to some more square root equations to solve. And a couple of days ago, we had some square root equations that we solved and cube root equations. So we squared both sides, or we took the cube of both sides, just depending on what the root was. So we're going to use the same technique. We're going to square both sides. Okay, so that's going to come out as 9x. Over here, so x minus 4 quantity squared. So that means x minus 4 times x minus 4. So you're going to FOIL. So first is x squared, outsides minus 4x, insides minus 4x, last plus 16 equals 9x. So put your like terms together. X squared minus 8x plus 16 equals 9x. Well, this ends up being a quadratic equation that we have to solve. And the two most common ways that we solve quadratics is by factoring or using your quadratic formula. So I'm going to move my 9x over here to the left. Either way, no matter which way we decide, you're going to need your equation equal to 0. All right, this will factor. So product sum table, multiply to get 16, add to get negative 17. So this is going to be a negative 16 and a negative 1. So you can go straight to the factored version here. You do not need a box on this one because your A is 1. And then I'm going to set each of these factors equal to 0. So x equals 16. And on this one, you're going to end up with x equals 1. Okay, now on these, when you get two solutions, you need to check them, okay, because sometimes you end up with an extraneous solution. So I'll show you what that looks like. Only takes a few seconds, not difficult to do. So I'm going to take my solution of 16. I'm going to plug it back into the original equation. So I get 16 minus 4 equals the square root of 9 times 16. Okay, so this simplifies. This is 12 equals square root of 144. Well, that's a true statement. 12 equals square root of 124 or 144. So we're going to keep the 16. All right, now what about the 1? Well, we're going to do 1 minus 4 equals the square root of 9 times 1. So negative 3 equals square root of 9, and that would be no. Okay, now if I'm solving a quadratic, so it's like x squared equals 9, square rooted, I get plus and minus 3, I get 2 answers. But if you're just simplifying, a straight simplification like we have here, then you want what's called the principal square root, and that's always the positive value. So that does not make a true statement in this case. So that solution is thrown out, and 16 is your correct solution. Okay, 61 is going to be similar. You're going to square both sides. So same thing we just did. And yes, you are going to need to multiply x plus 3 times the quantity x plus 3. So you can FOIL or you can put it in your box to multiply. Okay, so that's going to become x squared plus 3x plus 3x plus 9. Oh, oops, sorry about that. Okay, so this one, put like terms together again. You have 10x plus 9 equals x squared plus 6x plus 9. I'm going to move the 10x and the 9 over to the left. I'm going to just do them both at the same time. So this is 0 equals x squared minus 4x, and then those 9s happen to cancel out. So we have another quadratic to solve, but this time go with a common monomial factor. So remember, always look for that first. So x times the quantity x minus 4. I can now put my factors equal to 0. And yes, x equals 0 is one of your solutions. And this one would be x equals 4. Okay, so again, we have two solutions, but you want to take a second to check them because it is possible that one of them is extraneous. All right, so if I put 0, so this would be 10 times 0 plus 9 equals 0 plus 3. So this would be square root of 9 equals 3. Yes, true statement. I'm going to keep 0 as one of my solutions. Okay, I'm going to put in the 4. So it's going to be square root of 10 times 4 plus 9 equals 4 plus 3. So this would be square root of 49 equals 7. Again, true statement, keep the 4. So on this one, you're actually keeping both of the solutions. Okay, 62 might look a little intimidating because you've got square roots on both sides, but it really works out nicely because I'm going to square both sides. That cancels out those square roots. And you get 2x minus 5 equals x plus 7. So it's just a linear equation. So get x's on one side and constants on the other. And x equals 12. So just the one solution this time. Okay, 63. We're going to do the same thing we've done. So we're going to square both sides to get rid of the square root. Now this is going to be an x minus 1/2 times x minus 1/2. We'll deal with that in a second. Equals 1/4 x. Now it's fractions, and generally you all don't really enjoy fractions so much, but this one really does not really that difficult. Okay, now lasts 1/2 times 1/2. That's going to be a 1/4 equals 1/4 x. Okay, I've got some like terms to put together. So a negative 1/2 x and a negative 1/2 x, that works out nicely. That's just minus an x. And then I have the plus 1/4 equals 1/4 x. Okay, now we have a couple of options here. We can move the 1/4 x to the left, or if you want to take a second, we can multiply both sides by 4. And that's going to clear our fractions for us. So you may think that sounds like a good idea. So you're just going to distribute that 4. So 4x squared minus 4x, this becomes plus 1 equals x. Okay, it's a quadratic again, so I'm going to want everything on one side of my equation. Okay, now this one will factor. We will need to use a box, however. So product is going to be 4 sum -5. So a -4 and a -1. Oops, -1. Okay, so we're going to need to use the box because of that 4x squared, that leading coefficient of 4. So your box, first term goes in, 4x squared. My last term of 1 goes in. And then my values from my product sum table are going to fill out my other two spaces. All right, look for your common monomial that you can factor out in both rows. Down from the top, the columns, that can factor in x, and on this one will be a -1. They don't have anything in common, so it's a 1, but follow the sign of the first term, which is negative, and that's going to be a -1. Okay, then I can put these solutions equal to 0, x equals 1/4, and this one we're going to have x equals 1. Okay, so again, I would suggest taking your solutions, plugging them in to make sure they work. And on this one, I think both solutions work. Maybe I better check them just to make sure. Okay, put 1/4 in. Let's check 1/4. So 1/4 minus 1/2, does that equal 1/4 times 1/4? Okay, so this would be a 1/4 minus a 1/2. That's going to be a -1/4. It's equal to the square root of 1/16. That is not going to be a true statement. So 1/4 is out. Okay, so kick that one out. If I put in a 1 minus 1/2 equals square root of 1/4 times 1. So that would be 1/2 equals square root of 1/4. True statement. So we are going to keep the x equals 1. Okay. So last example to do, but I don't have time to go through that on this video. So I will include that on the next one.